go through question 11 first. Right. To all my homies overseas, enjoying your life, guess what? When you come back, you have to watch this. Yay. How fun. Okay. So you say you didn't get to do this, right? Okay, what's the answer for this one? So if you look at 60 degrees, that's what I mentioned before. All you need is a graph because you're given the graph. What do you get again? 1,000? 100. If you zoom in, which I can because it's a computer, it should be 1,200. It's 1,005. So this should be 1,200. Yeah. So you have to look at the lines clearly, especially when you have grid lines like this. Make sure you draw guidelines. So from this point here, draw your imaginary guidelines, dotted lines. Make sure you get this out. Find the reading on the air meter. So if the thermistor is currently at 1,200 ohms, what's the reading on the air meter? Let's see. The reading on the air meter is therefore the current reading, right? So what do we have here? We have something called EMF, and that's your V. Okay, we have this, which is your R, and this is your R. What does this mean? So do you need to convert? Yeah. So what's your I in the end?
It divided by 1,200 plus 2,000.
Yeah. So we are applying the V over R formula. R equals to V over I. Then you have I equals V over R. And that will give you plus 2,000. This should be 0.0025, I think. Could be off by 1 0. Yeah. It is my head. Because this is 1,000. So 8 over 32 is like a quarter. Quarter divided by 1,000 should give you this. Yeah. What is the unit? I see you did not put your unit there. Should be ampere. Always put your unit. You're looking at a 1 mark loss.
So if the question is 1 mark, if I don't put if I have 1 mark, 0 mark.
Depends on how strict the teacher wants you to be. You could get 0 marks. Be careful, man. Gabriel likes to do that. Oops, calling Gabriel out now. Gabriel likes to not put unit. He lost a lot of marks for his EOI. Yeah, so
You want to put we usually put units at
Hmm. Yeah. Um, Depends on how nice the teacher is, lah. That's what I'm saying. You may get like minus half. Yeah, if you don't put unit. So always make a habit to put units. It's kind of a waste. You're like 90% there, and then you didn't put unit, you lost 10%, you lost all the marks because of that 10% you didn't put in. So make sure you put that in. Potential difference of the thermistor. How do you do that?
So you could find
Yep. What's the I?
I
And what's the R?
would say 120 or 2000.
Well, it depends. Potential difference across the what? Yeah. Yeah. Okay. For this last question, there is something that you can apply that is called potential divider rule. You come across this sooner or later, so it's a good time to talk about this now. All right. So the potential divider rule goes like this. The V here, let's call it VT lah. The potential difference of the thermistor is equal to the resistance of the thermistor divided by the resistance of the thermistor plus the 2 kilo ohms multiplied by 8 volt, the total potential difference that you have. So that's why it's called potential divider rule. Um, in a way, it's a fraction. Because if you take that 1,200 ohms divided by that 1,200 plus 2,000, so basically what you have here is a fraction. That will give you, oh, I have too many zeros. What is that? Let's calculate that. Give me in terms of fraction. So it's basically saying that if my resistance is this much and my total resistance is this much, the amount of PD potential difference I should be getting from the 8 volt is a fraction of that. That's what it's trying to tell you. So the formula can be intimidating, the words can be intimidating, but it's actually a fraction.
Then so you're saying that the the Mr. takes up 3/8 of total.
Yeah, yeah.
So then the 15 go where?
What do you think? Who else is in the game?
To
The 2 kilo ohms. The 2 kilo ohms will take the remaining 58 of the PD. So think of it as like there are 8 slices of pizza. Um, like each bar 8, 3/8 of the slices. How much did he eat? How many did he eat? So it's 3/8. times 8, giving you 3. So in a way, because of this equation, you can then find out that the answer, the PD across thermistor is 3 volt lah. Similar to 3 slices. It's like a simple primary school math question. That's the interesting part about this. Yeah, you have something that is very intimidating, but if you take the ratio of their if you understand and realize that it's a fraction of the resistance to the total resistance, you use the fraction multiplied by 8, and you get an actual answer to the potential difference. So this is the introduction to potential divider rule. Naturally, there's a general equation which goes something like this. So V1 referring to whatever resistor that you are looking at. So you have two resistors, R1 and R2. V1 will be for resistor 1, V2 will be resistor 2, and you have V across here. So that's potential divider rule in a nutshell. If you have more, then you simply add the resistance underneath for the denominator. Okay? So this is the intimidating part of it. But the simple part of it is it's a fraction. It's all a fraction. There is something called a current divider rule, but we are not going to go through that today. That is a very good tool, but they don't teach that these days. So, did they not recognize the formula? No, it says they don't use that for secondary school levels. They use some of it in JC, but for secondary school level, I've not seen anyone teaching current divider rule. It's a very good tool actually. I could teach you more next time, and you can use it in exam if you want to.
And they won't mark you wrong.
They won't mark you wrong. Physics is physics, man. Like if you use the right physics concept to solve a question, who's going to fault you for that? Oh, this guy did not keep the syllabus. I mean, like this guy used something out of the syllabus and he's actually applying physics concept.
But like some teachers are like,
I think they just trying to tell you that, hey, keep to what you learn. But for O levels, they're not going to fault you for that. It's similar for primary school math. Who's going to stop you if you use algebra to solve? When you should be using parts and units. Yeah. Any mathematical problem sums can be solved in many different ways. And if you can solve it in a way that no other people have seen, I think that's something to comment about. Yeah, why not? Math is math also, ma. Okay. So anyway, we don't have to talk about this at this point in time. The reason why I will bring this out is because think about it. If you drop your thermistor resistance, because thermistor can change the resistance. All right. If you drop this, what do you think is going to happen to this? It will also drop. And it will drop below 3 volt, for example. So you can use that to answer this question.
so I just say the wattmeter decreases because the voltage is proportionate resistance.
If you use that, you maybe get like 1 mark or so. You're not going to finish everything because it comes back to change in temperature. So if you look at this, your VT decreases. You start with this, voltmeter reading decrease. So if your VT decreases, it will mean that your RT decreases. So if your RT decreases, yeah. So you got to use a graph to go and explain. Okay. So the point is, you have state first lah. Temperature increase. As VT decrease, RT decrease due to potential divider rule. Then from the graph, as RT decreases,
PBR is in our syllabus, right?
yeah,
But
me
not
check.
CBR. That's not.
yeah, correct. You're right. Okay. And that's it for this one. And then the next one is this one. You done?
Yes.
You write down, yeah. Okay.
This question, I don't explain.
Okay. So let's go through this one now. You have 10 volt variable resistor. Take note of the symbols. You may be asked to draw next time how to how to create a circuit with a variable resistor and a light bulb in series, for example. And then they ask you to draw. So the very first thing you do is to put in all the variables that are given. Did you do that? Otherwise, you may not get the answer, right? Okay, so you have I, you have V. So like what I mentioned, it can be challenging for beginners new to this topic when you see all the numbers and you don't know what they mean, you don't know how you use it. The best thing you can do is to write down all the numbers, put the relevant symbols inside. This is R, this is I, this is V. So what will be the answer for the first one?
2.5 over 2.5.
Yeah, because it's V over I. Yeah. Okay. So for presentation, you can write this lah. VR, because it's R, so you put a subscript R, 10 minus 2.5 equals to 7.5. And then you can use the same one. V over I. And what's that again? 3. Yeah. Or 15. Right. Okay. Okay. 30 ohms. Resistance of light bulb Q remains unchanged. State and explain what happens to brightness of light bulb Q. Okay. So one thing you can do is apply PDR. Apply what you learned from here. Okay. So let's try this. What would be the formula? VQ, let's put it here. What would be the PDR formula in terms of VQ? It will be the resistance of Q divided by, yeah. So it'd be like RR multiplied by 10. So if your brightness, if the resistance of R increases, this will increase. The rest will remain constant. So VQ will increase or decrease. It will decrease. So if VQ decreases, then what will happen to the brightness of light bulb Q?
So the total resistance increase.
Total resistance increase, yeah. But VQ decreases. Brightness in general is power.
Fair if explain how popular.
You can use V squared over R. So if you drop here, then this will drop. And R is a constant. You can say brightness decreases since VQ decreases. Okay, and that's it. Done. Yeah. What's the answer for this?
Put 1 over 10 plus 1 over 4.
If your answer is not 4.5, wait, S1, S3. Okay.
You say it's 1.5.
So if these two are close, what is the light bulb Q's resistance? 5, right?
Yeah.
So it'll be 1 over 5 plus 1 over 10 plus this. Do you add that? You could add a 4.5 inside, ma.
I did 1 over resistance A plus resistance.
What about Q then? S1, S3. Yeah, what about Q? Okay, if you do this, you're saying that they're parallel, which they are not. They're series. These two are parallel. So you got to add the parallel ones first, then add the series. How much is that? So you're going to round 3SF. And don't forget to put your units inside as well. So when you close S4, what happens?
The only light A and light B will light up. Because they are connected.
Only A and B will light up? No. You'd be wrong. This creates a short circuit. Now all the current will flow through here. And no current will flow through the B. So B will not be light up. Okay, when you close this and this S1 and S3, that's fine. They will light up. Q and A will light up. B will not light up. Light up. I keep thinking about lead. Yeah. No current flows through it. Short circuit on B. And that's it. We're done for this. Yay. So let's go for a break. And we'll come back with more work. More work. Okay, tell us.
And by source, the driver will charge around the complete circuit.
Okay. Done. Power source. In this case, the cells. Because answer in relation to the question. So it's about the cells.
Cells, where else can we put it?
It could be an AC power supply. They are not cells. More on that later. It could generate through a generator itself. Yeah. As you can see, it's a warm-up question. Do take note. It does come out. Okay. This is very interesting. What's the answer for this?
All the measures the total EPD of the user base.
TPD. Okay. What's TPD? Oh, potential difference. Okay, I'm gonna circle out. I'm gonna draw 3 circles, and you can tell me which ones is done correctly. In the diagram, which one is a mistake, which one is not a mistake. Circle number 1. Circle number 2. Circle number 3.
Two of the mistakes.
Hmm?
Give me again.
1 circle is correct. 2 are mistakes. Mistakes. So the battery is fine.
Okay.
For the batteries to face this way is fine. Are you sure about that? Yeah. Battery should be made this way.
People, plus you
I can clearly see from here. I'm like a meter away from you. I could see that is a mistake. Oh my God. Right. Okay. So what's the issue with number 2? Circle number 2.
the measures the total current through the whole circuit,
And then
not the step.
complete the sentence for me. Ammeter should be connected in. Exactly. Is this in series? Is this in series? You don't know the meaning, the difference between series and parallel, right? This is parallel. Series should have been here. This would be correct. So write that down. There's no issue with number 3. Voltmeter should be connected in parallel. So what happened to batteries? Is there going to be a current flow? No current flow, ah. This is 0 PD. Connected wrongly. Terminals are facing each other. So there is no current flow. Number two, ammeter is connected in parallel. Ammeter is connected wrongly, as it should be connected in series. No current will flow through the rheostats of variable resistor. And so the resistance cannot be determined. Okay. So make sure you have all the points inside. It's a 4-mark question. A lot of times you likely get wrong if you're new to it. But now you know. Always look at the circuit and figure out what's different. What looks different from how it usually looks. Okay. Then you can put your answer down. I think there's a printing error. And see if you get a mark for that.
Like in exams, you get 4 marks, right?
Usually there won't be lah. But if so, yeah, possible. Or they just void the question. Yeah. Okay. Are you able to answer this? The resistance or is I'm going to assume that it's working well lah. If not, then this question is weird. Technically, I can say there's no current flow, so based on the previous configuration. But let's assume that the circuit is working. Assume the circuit is working. Okay, what's the answer for this? Okay. And why? Mm-hmm. Uh-huh. Continue.
Same current flows through.
Sure. So why would the resistance increase in resistance cause a decrease in I?
Plus, what is it? Information.
Since I equals to V over R and the EMF is constant, the I will decrease, the current decrease. So make sure you come back to the relationship. My nose feels blocked today, man. I don't know why. It's very strange. Ah, so when you see like potential difference, right? Try to use potential divider rule. How would you answer this?
So, no, first, you want to say that the potential difference will increase
Okay. Uh-huh.
as the distance
Yeah. You gotta apply PDR. But PD of variable resistor will increase. Alternatively, V equals to IR. No, you can't use that because your I decreases. No, you only PDR. Yeah.
R equals
So your V of the variable resistor would then be R1 over R1 plus R2 times E, which is the EMF. Since your R1 has increased, your V1 should increase as well. So that's how I use it. Numerator increase, then everything else will increase. It's all math. Okay. I would assume you can do this. What's the formula to use? Yeah. How do you know? Put down the symbols first. Q equals IT because it has both I and T. Kit Kat.
yes.
This one is a easy peasy, yeah. What is it, 60?
Yeah.
60 watts. Very good. 60 coulombs. Yay. Let's go, man.
So that is good.
Okay, you see the E field going out, electric field pattern. You see the E field going out. This is a plus, and this is a minus.
Right.
Then it'll be C. No, it'll be D. Okay, going out, going in.
Then how about the arrow? Why is it pointing that way?
Here.
So, why don't you?
Okay, so a plus, right, would have something like this. A plus by itself would be something like that. A minus by itself would be something like that. So what happens if you bring them together? Then they start curving towards each other, lah. That's how you get this pattern. Yeah. So these field patterns are because of the presence of, it's based on what if you have a positive charge over here. So you put a tiny positive charge, where will it travel? It travel here, lah. If you put a tiny positive charge here, it will travel here. So the idea is to draw a field pattern based on the path of a tiny positive charge, a test charge, they call it.
So, in the teacher papers, they ask us to draw this.
They may. Yeah.
Why did you make how many marks? So,
It's a good 2 marks.
it's like 5.
No, because it's very simple. It's like copying for the notes. They don't give you, they give you a lot more marks for a question like this. Because it's hard. Explain. explain questions generally are harder and have more marks. You want to get an A1, you gotta know how to do questions like this. Yeah. Knowing how to do question like this probably get you like a C5 to a B4. Yeah. Yeah. This one, a C5, B4 to B3 level. So every one of them will have different set of questions, different levels. How about this?
Answer is B.
What formula do we use?
R equals EL over A.
Rho L over A. Is the rho the same for the two wires? Because it's similar, so the rho is the same. So you're always comparing the L and the A. 2 meters compared to 1 meter. How many L is that? If 1 meter is L, 2 meters is 2L. If 1 meter is L, 2 meters must be 2L. If A is 2, 4 will be how many A's?
2A.
So you can put this inside. I should use a new one. Better in terms of presentation. So this is 4 ohms currently. So the R new, let's call it R new, is rho 2L over 2A. And what do you get? Which should also be 4 ohms. Because if rho L over A is 4 ohms, then this must be 4 ohms. So the answer is B. Did you get it?
Yeah, like,
Algebra is your best friend, man. You could find out the resistivity. You could find rho first.
that's quite good.
Then you take 4 times, yeah. Then you got to convert to meter square. Yeah. You save a lot of time if you do this. Take note, MCQs is 1.5 minutes to do a question. Yeah. So save time. Use this. Okay. First, what you want to do is to find I. Do you find it?
I use E equals W over Q.
Okay. What do you use for W then?
Yeah,
That's where you're wrong, lah. W is work done. It's in joules. That's 48 watts. You can, however, use 48 times 2 times 160. If you want to use that, this should be the right way. Oh, no need to times 160 because it's in seconds. Times 2 then. Okay. And then your E should be 12 volts. Oh my God. Every time. It's fire, it's fire. Yeah. Okay, what do you get for this?
yeah, 30 seconds. Then there's two.
So this will give you 4 times 2. You give you 8. So answer is D. Your answer was what?
Lucky also.
What?
Yeah, because I thank you. Yeah.
Lucky you. Make sure you use the right formula. What's next?
This W equals Q E.
Use this.
Yeah.
Okay. 100 times 12. 1002 joules.
Yes.
Okay. This one you can Keep. It's fine. But for benefit's sake, uh, the answer, just for doing the question, for the sake of doing the question, the answer should be if you touch the neutral, uh, that's possible. Earth is green plus yellow. Neutral is blue. Life is brown. So these two will happen, these two will cause a short circuit. Damage wiring most of the time. Over time, wear and tear, the wiring tends to come out. So when you look at your live, neutral, and uh, earth in the plug, like this.
Yeah.
So over here, you have all your live, neutral, and earth in one single wire. Obviously, they are separated from each other with insulation, but they are put together in a single wire like this. So over time, if like, you happen to be pressing on something, like you put something heavy on it and you press the wire, it's going to cause all the wires to be squashed under the weight. And that may cause the insulation to be damaged. And then they will start. The moment it's damaged, right? They come into contact with each other.
What's that fire?
It used to.
Used to.
So in the past, a lot of fires were caused by this problem. So when they are damaged, right, then the current will run through like that. Then you get a short circuit. So in the past, fuse wasn't invented. So if this is damaged, right, all the current will just run into itself. The current that comes out from the live will go back to the neutral. It will keep running, and the current will be very big. Over time, you're looking at electrons running at a very fast speed, giving off a lot of heat. So this will catch fire. Then the whole thing will burn. And that's how we have fires in the olden days before fuses were made. So the government made the rule that, every household needs to have a circuit breaker, needs to have a fuse because of issues like this. Okay? Ah, we'll leave the rest for next year. Huh? Oh, you do. I've given it to you. So that'll be your homework for next year.
The keyword.
The keyword is do your homework for next year. All right. Ishva and Gabriel, make sure you do these questions. Samuel's not supposed to come. Samuel's got his BB. All right, and we are done.